Welcome back everyone. In today's session we are going to continue with exercise 2 of triangles. In the last session we studied the similarity rules. Quickly we will recall it. We'll recall all the similarity rules and we'll jump to the exercise questions. So I discussed 3 similarity rules with you in the last session. The first one was angle similarity. The second one was SSS, side, and the third one was SAS, similarity. So if you remember these all the similarity rules, then you can easily solve exercise questions. The whole exercise depends on these 3 rules only. So we are going to solve the exercise questions in today's session. So let's quickly recall it. So I said you that if two angles of one triangle are equal to two angles of another triangle, then those two triangles are similar by AA rule. I said you the third angle will be equal anyway, okay? So you can skip it or you can include it, that's your choice. So in this case angle A is equals to angle D, angle C is equals to angle F. So these two triangles become similar, okay? Then I also discussed with you about SSS similarity. That is, three sides of one triangle are in proportion with three sides of another triangle, okay? So just we'll see the ratio here. So if three sides of one triangle are in proportion with three sides of another triangle, then also those two triangles will be similar by another rule, that is SSS rule. Then I discussed with you about SAS rule also. In this rule we need two sides in proportion and included angle, okay? So you can see the blue colored lines and the green colored, okay? These two are in proportion, AB by DE. The ratio of AB and D by DE is equals to the ratio of BC by EF, and the included angle is angle B and angle E. So they are equal, hence these two triangles are similar by SAS. I said you about the similarity symbol. The symbol which we use for similarity is this one, okay? So we'll continue with the exercise questions in today's session. Let's do the second question of exercise 6.3, okay? We did the first question. Now coming to the second question. In this, few angles are given and we have to find few of them. In the given figure, ODC is similar to OBA. You can see here, first thing is given, ODC is similar to OBA, okay? So now angle BOC is given as 125 and CDO is given as 70. So this angle is given as 70 and this angle is given as 125. We need to find the other three angles, DOC, DCO and OAB. So let's see how to find. This is nothing complicated. We can use any rule of geometry which you learned in the previous class also. So you can clearly see this is a linear pair here. I can use linear pair axiom and I can find angle COD, or I can say DOC. I can find angle DOC by using linear pair axiom, okay? Because BD is a line. So BOC plus DOC, these two angles, if I add up, I'll get equals to 180 because it's linear pair. So 125 plus DOC is equals to 180. So DOC is 180 minus 125. 125 goes to the right, it becomes minus 125. So DOC is equals to how much? DOC will be equals to 55, okay? 55 degrees. Next, in triangle DCO, so I got DOC as 55. Now in this triangle DOC, DCO or DOC, this is 70 degrees, okay, and this is 55 degrees. Just now we got it. So we can find the third angle by using angle sum property. So that is, sum of the angles of a triangle is 180 degrees. So we can find angle DCO. This angle I can find by using angle sum property. You know very well what is angle sum property. So 70 plus 55 gives you 125. So DCO will be equals to 180 minus 125. That will also be 55 degrees. Okay. So we found two angles. We found DOC. We found DCO. Okay. What is the leftover angle now? We have to find the leftover angle, that is OAB. So let's see how to find the angle OAB. It is given that these two triangles are similar. Okay, a triangle ODC is similar to triangle OBA. So we can say that angle DCO, whatever is angle DCO, same will be OAB. Okay, OAB. So what will be OAB here now? Because DCO is 55, OAB will be also 55 degrees. Well, now why they will be equal? Let me tell you that. When these two triangles are similar, it's given that these two triangles are similar, then the corresponding angles of those two triangles will also be equal. That is, angle, here you can see the first letter of these two triangles, angle O and angle O. So angle O is common, that is vertically opposite angles. Then angle D will be equals to angle B. Angle C will be equals to angle A. So in that way I can say angle DCO is equals to OAB. So when two triangles are similar, the corresponding angles are equal. Keep this in your mind. We can use this in any problem. Okay, whenever triangles are similar. So angle O is equal, D will be equals to B. Okay, if angle D is 70, B will also be 70. Angle C will be equals to A, because the triangles are similar. Now let's go to the next question. In this question number 3 of exercise 6.3, it's given diagonals AC and BD of trapezium ABCD. You know what is a trapezium? Trapezium is a quadrilateral in which one pair of side is parallel. So ABCD is a trapezium with parallel sides AB and DC. AB is parallel to DC given to us, and the diagonals AC and BD intersect each other at point O. Now we have to prove that by using similarity criterion. We have to prove that OA by OC, the side OA by OC, is equals to OB by OD. We did this theorem in the previous exercise, but there we used BPT. Here we can use similarity. Okay, in the previous exercise we drew a line and we proved it. Here we can prove directly because we know the similarity rules. So let's write what's given now. Given is ABCD is a trapezium with AB is parallel to CD. Diagonals AB and CD intersect at O. We have to prove. So let's write what is RTP. We have to prove that OA by OC is equals to OB by OD. Which rule I can use here now for proving these two triangles are similar? If I prove two triangles are similar, then only I can write this ratio from it. Okay, so I'll try to prove that green colored triangle OAB is similar to the blue colored one, that is OCD. I can use alternate angles, corresponding angles, any property I can use here. Okay, so let's use alternate angle property here and try to prove these two triangles are similar, because I have to get a ratio from it. So you can see here AOB is equal to DOC. I can say these two angles are equal, vertically opposite angles. Then I can say this angle is equals to this angle. Okay, alternate angles. And I can also say this angle is equals to this one. They are also alternate. So three angles of the green colored triangle are equal to three corresponding angles of the blue colored triangle. So I can say these two triangles are similar. Yes, three angles are not required. Okay, we can even say by two angles also. I can just use this alternate angles and the other alternate, but third angle will also be equal, as you know that. So these two triangles are similar by triple A similarity rule. So when these two triangles are similar, I can write the corresponding sides are in the same ratio. Okay, when triangles are similar by triple A similarity, then I can say the corresponding sides are in the same ratio. So how to write corresponding sides? That's very simple. You have to see this name of the triangle. First two letters OA by OC, okay, will be equals to OB by OD. Okay, whenever you are adding similarity of triangles, just let me show you the trick of writing it, the corresponding sides. Imagine if these two triangles are similar, OAB is similar to triangle OCD. So when you want to write corresponding sides of these two triangles, you can just take first two letters and the first two. OA by OC will be equals to AB by CD, or the second two, then first and last OB by OD. This is the way we can write corresponding sides are in the same ratio. Okay, so as I don't require AB by AD, so I am excluding it. So I am writing OA by OC is equals to OB by OD. So hence it is proved. Let's practice writing the corresponding sides of similar triangles. Imagine if you have two triangles, say triangle PQR similar to triangle ABC. Okay, so ABC, sorry. So what are the corresponding sides in these triangles? We can easily write PQ by AB. Okay, PQ by AB, then the next two QR by BC will be equals to QR by BC, the last one PR by AC is equals to PR by AC. So this is the way we can write corresponding sides if two triangles are similar, and when two triangles are similar, the corresponding sides are in the same ratio and corresponding angles will also be equal. So I can say the corresponding angles. What are the corresponding angles in this? I can directly say angle P is equals to A, angle Q is equals to B, angle R will be equals to C. So whenever two triangles are similar, you can easily write the corresponding sides and the corresponding angles, any one of those, whatever is required. Okay, thank you.